All right, good morning or good afternoon or good evening or whatever time slot you're watching this video in. Welcome to my kitchen table. I am going to work the odds of the calculus review. And I haven't really looked at this much, so I'm just going to work it cold and we'll see how it goes. Number 11. Remember, we already did page 1 and 2 together. And so that I'm not going to worry about. Answers are posted to those with work shown. Reminder, calculator goes for 1 through 23, so we're still in the calculator section. But that doesn't mean we'll necessarily need a calculator. Number 11. The function is continuous, differentiable, over the interval -4 to 6. So from -4 to 6, it's continuous and differentiable. F of -4 is 3. F of 6 is 23. Okay, so that's way up there somewhere. But it's enough to get a picture of what's going on. Tell whether the statements must be true. Must be true. So it's not might it be true, it has to be true for us to give it the true mark. Over -4 to 6, the function has a maximum value. Let's see, how else could I get there? Regardless of how I get from 4 to 6, there's got to be a maximum in there somewhere. There might be more than one. It could have like two peaks that are the same, but it's going to have a maximum somewhere between -4 and 6. Over -4 to 6, there exists a value such that f of c equals 0. Well, no, not necessarily. If we just go straight from just draw a line connecting the dots, there wouldn't be any zeros there. Now there might be a 0, but we can't say for sure that there definitely is a 0, so that one gets a false. Over -4 to 6, there exists a value such that f of c equals 10. Well, this was 3, this was 23. 10's in there somewhere. Well, if we're going from y equals 3 to y equals 23, we got to pass through 10 somewhere. And maybe we pass it once, maybe we pass it 100 times, but we go through there somewhere. That's true. That's the fancy name is the intermediate value theorem. 10 is intermediate to 3 and 23, so we got to go through there at some point. Over -4 to 6, there exists a value such that the derivative is 0. Maybe, but maybe not. So who knows? If we just go straight there, we don't have a derivative of 0. But if we have any that have any maxes or mins, then we would have zeros. So that gets a false because it's a maybe, maybe not situation. There exists a value such that f prime at c equals 2. Well, maybe it seems weird that they picked 2. I wonder what the average rate of change is over the whole thing. So 23 minus 3 over 6 minus -4. Average rate of change is 2. They're saying the derivative equals 2. But by MVT, IROC equals AROC somewhere between -4 and 6. So this is true because of the mean value theorem. Over -4 to 6, f is increasing. That's worded a little bit strange. Generally speaking, it's increasing because it goes from a lower number to a higher number. But I don't think we can just say it's increasing the whole way because it might go up and then come back down. So I think that one gets false. Over -4 to 6, the derivative exists everywhere. Well, yeah, by definition it says differentiable. Differentiable means derivative exists. So that one's a true. That's just kind of testing if you caught that differentiable means has a derivative and f prime means derivative. So that one's definitely true. Again, just in the interest of time, I'm doing every other one. Number 13. The graph of y equals x to the 2/3 is shown above on the interval -5 to 5, which is true. The graph is continuous and differentiable over the interval. Well, clearly it's continuous. You can tell by looking. Differentiable, maybe it's hard to tell right there, but that's a cusp. And if we wanted to make sure, we could take the derivative and we'd get something like that. And if x was 0, that would be a problem. So it is not differentiable, but it is continuous. So A is out. The graph is continuous. Yes. Not differentiable. Okay, I like answer B. Let's keep going though. The graph is not continuous. No, that's not true. It's continuous. The graph is not continuous. No, it's continuous. So yes, it's answer B. 14 we're not doing, but that was an old test question. It has to deal with the derivative is, or the function is 0, the slope is positive, but the concavity is negative, and so you can kind of put those in order. Number 15. Given f of x equals that ugly thing, find the interval of x coordinates for which the graph of f is concave up on the interval 0 to 0.78. That seems a weird interval to go for. Let's see. Concave up means that f double prime is positive. We could also say that f prime is increasing. And doing it this way might make our lives a little easier in the calculator, because I won't have to find double prime. I'll just have to find the first derivative and then look for where it's increasing. So let's see if we can use this rationale to figure out where it's concave up, just so that we don't have to find the second derivative, because this looks kind of ugly. So the derivative would be 2 times 4 times sine cubed of 2x. Derivative of sine is cosine of 2x, and derivative of 2x is 2. Yeah, I don't want to do a second derivative of this. The second piece, bring the 3 down. 3 times 3 is 9. Sine squared of 4x. Derivative of sine is cosine, and derivative of 4x is 4. So chain rule, chain rule, chain rule on this problem. I guess the good news is we're ready to go to the calculator. Maybe I'll clean it up a little bit here. 2 times 4 times 2 would be 16. Sine cubed cosine of 2x. And then 9 times 4 is 36. And there's probably some crazy trig identities that would help us with that, but I don't want to mess with that. I just want to type it into my calculator / phone here. And oh, that's really close to the function right there, but 16 sine 2x cubed cosine 2x. Whoa. So sine cubed, then cosine 2x minus 36 sine of 4x. Whoops. Sine 4x squared times cosine of 4x. Okay, what a mess. I'm just rechecking to make sure I have this in there correctly. I think I do. Window, it told me to look between 0 and 0.78, which seems a strange window to look at, but whatever. I am looking for where it's increasing and decreasing, so let's just go with -5 to 5 and see if that's good enough. If it's not, we'll fix it. Uh-oh, I wonder if I'm in degrees. I suspect I'm in degrees since I'm not showing anything. Oh, there's a little bit. Yeah, radians. There we go. Okay, and we want to know, what's the question asked while it's graphing? F is concave up, where f prime is increasing. This is the graph of f prime. So I would like to know where that graph is increasing. So from down here to up here, so I'm not looking in a big enough window to know. -10 to 10 maybe. No, still not enough. Okay, but again, I know where I'm looking. F prime is increasing. I'm looking at the graph of F prime. It increases from somewhere down here to somewhere up there. But I don't know where those somewheres are yet. And again, this is why you have a little more time on the calculus part of the AP test, because they know it takes a little bit of time to play with your window, to figure out, to type it all in. I got the bottom part. I don't quite have the top part yet. Window. Let's just go to 25. That should be more than enough. And the calculator can find a minimum of this graph, and it can find a maximum of this graph. And so between this x value and this x value, f will be concave up because f prime is increasing. So second calc minimum, left bound. You can't see it exactly, but you can have a big enough bound where it doesn't matter. Like come all the way over here. Enter. Right bound. You can also pay attention to your y value and see where it starts increasing again. Left bound. Guess. So this x value, 0.228. Now again, this is not an ordered pair. This is an interval. So from 0.228, where f prime is a minimum, to wherever f prime is a maximum. Again, it's taken a while, but you have the time on the calculator part of the test. Right bound or left bound, right bound, guess. 0.544. So from 0.228 over here to 0.544, f prime is increasing. That means f double prime is positive. That means f is concave up. All right, 16 we can skip. Well, I bet you can do it. 17. The graph of f is shown in the figure above. Okay, so this is f, not f prime. Which of the following could be a graph of the derivative of f? Okay, so I'm looking for like slopey things here. So slope is negative until here. So f prime is negative and then positive to there. Oops. And then negative to there and positive after that. And it's got 3 zeros. So I need something with 3 zeros. Nope. Nope. Too many zeros. 1, 2, 3 zeros. Maybe. F prime is negative, positive, negative, positive, negative, positive, negative, positive. So I'm good with part C. Number 19. Two people are walking away from each other. One heading north at 3 miles per hour. Let's just call that y. So dy dt equals 3 miles per hour. The other heading east. Let's see, east would be this way. At 4 miles per hour. Maybe a 3, 4, 5 triangle somewhere in here. Maybe not. How fast are the two people moving away from each other after walking for 2 hours? Okay, so 2 hours later, this guy's gone 6 miles, this guy's gone 8 miles, and we want to know how this distance is changing. So dd dt. And I guess I'll switch to A, B, and C. No, I can still use this one. So y equals 6, x equals 8, d equals 10. A squared plus b squared equals c squared. 2a dA dt. Whoops, I was doing x's and y's. So x squared plus y squared equals d squared. dt. There's a lot of d's in that one. I could divide all the 2's out, make life a little easier. So x dx dt is 8 times 4. Y times dy dt is 6 times 3. And d is 10. So my answer, if I want a safe stop, would be 8 times 4 plus 6 times 3, all divided by 10. It's a calculator question. If it's multiple choice, you'd have to multiply that out. Let's see, 32 plus 18 is 50, divided by 5 is 5. I don't know if that's a 3, 4, 5, or if that's a fluke, or if that's why it's that. Skip number 20. Well, no, you don't skip number 20. I'm going to skip number 20. 21. Given f prime, okay, so it's a derivative, at which coordinates below does the graph of f of x change concavity on that interval? Did we just graph this one, or did we graph the derivative of that? I think we did. Well, we would need the derivative anyway if we're talking about concavity. That would be f double prime changes signs, but it would also be f prime changes increasing to decreasing, or the other way around. Well, that's what we found on that other page. If that's the same, is that the same function as what we had way back here? 2 sine to the fourth of 2x minus 3 sine cubed 4x. Okay, that was the same. Oh, that other function f was equal to that. Now we have f prime equals that. So I would put this in the calculator. That way I don't even have to take a derivative. 2 times sine of 2x to the fourth minus 3, whoops, did the same thing last time, minus 3 sine of 4x cubed, oops, cubed. And I'm looking for where f prime, that's what I have a graph of, changes from increasing to decreasing, or the other way around, because that would be a change in concavity. But I only care 0 to 2, so I need to go change my window again. Window 0, oops, 0 to 2. I don't need that big of a y min and y max. Let's go back to negative 5 to 5 and see if that's good enough. So there's a change of concavity there, not there, there, and there. So there could be more than one answer. That one might be 1.9. That one would be pretty low. I don't know. Let's go try this one. Second calc. Hold on now. What was that one? So that's a minimum. Second calc minimum. Let's go find the location of that. Left bound, right bound, guess 1.938. Yep. So that's a place where f prime changes from increasing to decreasing, or I guess decreasing to increasing. But that means f double prime changes signs. That means f changes concavity. So you got to keep all those things in mind in order to answer some of these questions. 23. If velocity equals all of that, find all these things when the particle changes direction. So that would mean v changes signs. Well, I don't want to solve that for 0, but that's why I have a calculator. So this will be a little easier than that sine stuff to put in. 2x cubed minus 15x squared plus 24x plus 1. And it doesn't give us a window to look at, so I better be careful. Let's go to 10 just to be careful. So where does it change signs? Well, there and there is the only places I got to worry about. 1, 2, 3, 4, 5, 6, maybe 7. I could go to 7 and be fine. And it might be better to see more of the graph. Well, I didn't see all of it, but that's fine because all I care about is those two spots. Second calc 0, left bound, right bound, guess, no sign change. Oh, if that happens, it probably means I did not include a 0 in my range. So left bound is positive, right bound needs to be negative for this one. So t equals 2.389 for one of the answers. Second calc 0. Scrolling, scrolling, scrolling. There it is. Left bound, right bound, guess. And t equals 5.152. Both of those in seconds. Particles moving to the left when v is negative, so I can look at my picture and just say v is negative in between those two points, 2.389 to 5.152. So no extra work required for that one. Increasing speed. That means A and V have the same sign. So that would mean I need to find A, 6t squared minus 30t plus 24. I was worried about that, but this turned out to be kind of easy. T minus 4 and t minus 1. So from 1 to 4, see if I plug in 0, I get positive. If I plug in 8 or 10 or 12, then this 6t squared takes over, I get positive, and it's negative right there. So now I need to look at that graph along with my velocity graph, kind of think together here. So velocity is positive from 0 to wherever that is, but that only matches up to 1. So from 0 to 1, they're both positive. It goes negative at that point, which we already found was 2.389, and stops at 4. So 2.389, comma 4. And then they're positive. The velocity turns positive at 5.15. Acceleration's already positive there, so 5.15 to infinity. For what time intervals is the acceleration positive? We just found that out. 0 to 1 and 4 to infinity. Alright, I'm going to stop the video there and we'll pick up the no calculator section in a different video.